The new Series 4000 Tier 4 mining engine was developed to meet the most stringent off-road emission mandates from the Environmental Protection Agency, EPA, without the use of any exhaust aftertreatment. Come take a trip with us through this engine and see the robust, sophisticated technologies which we applied to realize this economical and ultra-clean emissions engine. The engine runs smoothly thanks to the perfect integration of its proven components, which have made the Series 4000 MTU's most popular product family, with more than 26,000 engines sold since its launch in 1996. Inside the engine, fuel and the oxygen in the air interact to transform chemical energy into power. Follow the airflow through our engine and discover all of the key components which help to efficiently lower emissions. These components are the high-pressure common rail fuel injector and pump, the two-stage intercooled turbochargers, the cooled exhaust gas recirculation system, and the engine electronics. Together, these technologies deliver very low particulate and nitrogen oxide emissions without requiring aftertreatment, additives, or the related infrastructure. First, the engine takes in air. It flows through the air intake pipe to the turbocharger, where it is compressed to pressures of up to 5 bar. Hot pressurized exhaust gas drives the turbine up to speeds of several tens of thousands of revolutions per minute. R&D specialists are constantly working to develop this key technology. With two-stage turbocharging, optimum charging efficiency is achieved by using a charge air cooler located between the two compression stages. The air heats up significantly during high-pressure compression. It needs to be cooled again before it enters the combustion chambers. The charge air coolers perform this task. The highly efficient charge air coolers developed by MTU and its suppliers help to reduce the emissions created during combustion. The cooled, compressed air enters the combustion chamber through inlet valves. In the combustion chamber, the air is again compressed by the piston. The injector sprays in fuel, which mixes with the air. The mixture has to burn cleanly. This is achieved by precision injection and by a piston bowl shaped to perfectly match the injection flow. MTU has decades of experience with efficient combustion designs. That's why the exhaust gas which leaves the Series 4000 combustion chamber is extremely low in pollutants. In our EPA-compliant engines, some of the exhaust gas is rerouted back to the combustion chambers. The exhaust from several cylinders, the donor cylinders, is used for this purpose. The hot gas from the donor cylinders is cooled and reintroduced into the combustion air. The inlet valves allow the combination of exhaust gas and fresh air back into the cylinders, where it mixes with the fuel injected to allow combustion to take place. This proven technology has been perfected on diesel locomotives driven by MTU 8-cylinder Series 4000 rail engines since 2004. Combustion processes which use exhaust gas recirculation need very high fuel injection pressures. This makes it possible to achieve low levels of nitrogen oxides together with low particulate emissions. The orchestration of all the shown technologies results in a new industrial engine with no need for exhaust aftertreatment to meet the final non-road EPA regulations. In addition, fuel consumption is reduced up to 5%. This enables OEMs and mine operators to improve their bottom line. The lower exhaust emissions, lower fuel consumption, and less complicated maintenance will minimize costs. Taking the demanding requirements of mining applications into account, MTU engineers were led to an engine design with nearly the same dimensions as the existing Tier 2 Series 4000 engine. The engines are robust, reliable, and cost-effective workhorses. able to fulfill the required tasks even in dusty, harsh open pit operations, with temperature extremes and high altitude. For the mining industry, the Series 4000 is the solid platform to ensure customers' current and future success, providing the best power-to-weight ratio, very low fuel consumption, compact physical dimensions, thermal protection for added safety. Together, these factors make the Series 4000 the best solution for mining equipment requiring Tier 4 final emissions levels.